Hello everyone! Today I would like to do single area OSPF version 2 configuration, including implementation of OSPF network optimization features. But before we continue, I would like to ask you to subscribe to my channel with notification bell on and also show your support by hitting like button to this video. So let's get started. So this is network diagram to complete. We need to do OSPF area 123 configuration on R1, on SW2 layer 3 switch, and on SW1 layer 3 switch. This switch is unmanaged. I'm not going to touch it, and then I want to configure default route to outside network and advertise it to OSPF area. Then I want to configure also passive interfaces, these four facing PCs. Then I want to change some OSPF cost and to show how to do reference bandwidth adjustment. Then I want to play with timers, and at the end I'm gonna do DR and BDR placement. Okay, let's configure it. This is our network. I already configured IP addresses on all devices, so we just can check. Show IP, interface brief. As you can see, we have outside IP, inside IP on these interfaces. Let's check SW1, show IP interface brief. All IPs are there and interfaces up. Interface brief. Okay, let's try to ping 10.123.0.1, which is our router R1. Successful. And let's check IP on the host. Okay, and let's try to ping gateway 10.24.0.254. Successful. So we have connectivity. I can reach from host here, and I can reach from this one here. Now let's do configuration for OSPF. Conf-t router OSPF 100, router ID 111. On this one I'm going to use I'm going to enable OSPF per interface. So interface G01, I need to enable only on this interface. I don't want to enable on this one. IP OSPF 100, area 123. Okay, show IP protocols. As you can see, router ID and routing on interfaces configured explicitly G01. All good. Let's go to next one. Conf-t router OSPF 100, router ID 222. This one I'm gonna enable first on explicitly on the interface with IP 10, let's say 11.0.254. 000. This will enable OSPF only on the interface with this IP address. 1, 2, 3. Next one I'm gonna do for network 10, 12, 0, 0, 0, 0, 0, 255 area 1, 2, 3. So this command will enable OSPF on the interfaces, IP addresses of which are in the range of this subnet. The same you can extend, let's say, to enable on all interfaces. So we're gonna put all zeros here and here all 255s. And the last one, 1, 2, 3. Okay, show IP protocols. Router ID, networks, all good. And let's see if we already have adjacency formed with router R1, show IP OSPF neighbors. Yes, everything is fine. Let's go to SW2, conf t, router, OSPF 100. And let's do it like this, 00000 area 1 to 3. So this one is going to enable on all, no, I'm wrong, sorry. I just set this one 255, 255, 255, 255. This one is going to enable on all networks, on all interfaces on this router. Okay, and show IP protocols. You can see router ID, gateway distance. Okay, show IP route OSPF. We can see these two networks. It's fine. It should be like this. Then show IP OSPF route OSPF. And here we see this 1023, 1024. These two networks. It's okay. Let's do show IP OSPF neighbors. Show IP OSPF neighbors. As you can see, router ID of router or switch layer 3 switch SW2 is the highest IP address on the app interface. So let's change it. Conf t router OSPF 100 ID 333. And now it says that I need to reset OSPF process. And for now, it's still with this one, but in configuration, show run router OSPF 100. It's already 333, but to take for this command to take effect, we need to reset process. Clear IP OSPF process. Yes. And now let's see on this one again. Show IP OSPF neighbors. And I can see I already have this router with router ID 333. We still have this one, but it's gonna disappear once this the timer reach 0. Let's see this. Let's just wait a little bit. So next one, I'm going to configure default route on this router R1 facing outside, and then advertise this default route into the OSPF domain to all routers. And now you can see this one disappeared. Everything is okay as planned. Let's go. Conf t route IP route 000 and G00. So router OSPF, to advertise it into all OSPF routers, I need to enter this command default information originate. There is also option to always or metric. Always advertise default route always, and metric if you want to change metric for this route to specific if you want. Okay, let's see what we have now. Show IP route OSPF. So as you can see, we already have our default route through this router R1. Okay, and let's do through router R1 on this one. Show IP route OSPF. Here as well. Let's check if I can ping my 192.168.1.1. This is my Wi-Fi router, which is sitting over here. So I'm pinging from R1, but I will not be able to pin it from this one. Pin 168.1.1. I'm not able, I have route external, the default route to anything, but I cannot ping because my Wi-Fi router doesn't know anything about this network on this router to where send reply back. So I need to configure, if I want to ping from this one, from SW1 and SW2 or my host, I need to configure NAT on this router. Conf T IP access list standard 1 permit for all my networks, let's say inside networks, 255, 255, 255. Conf T IP NAT inside source list 1 interface G00 overload and interface G00 IP NAT outside, interface G01 IP NAT inside. Okay, let's see if we successful. Yes, and as you can see, show IP NAT translations. I have translated this address of switches W1 G00 interface into outside IP address of router R1, and I can ping my router. I was not able, but now I am able to do it. So this part is done. Next one, let's configure passive interfaces. So if interface configured as passive in the OSPF is not gonna send or receive hello packet. So it's not gonna, like, it's good from security point of view because I don't see anything on these interfaces if I connect and try to listen traffic. So let's do it on this and this interface and on this interface and this one. Conf T router OSPF 100. Oops, sorry. No router OSPF 1000. Router OSPF 100. Passive interface G01 and passive interface G02. Show IP protocols. And you can see these two passive interfaces. This is the way to check, one of the ways to check if the interfaces are configured as passive. And here, conf T router OSPF 100, passive interface, same G01 and G02. Let's see. We have these two interfaces. Okay, and next what I wanted to discuss is link cost. What we have now at the moment, we have show IP OSPF route, or show IP route OSPF. We have cost to network 23 and 24 too. As you remember, calculation of this cost is a reference bandwidth divided to bandwidth of the interface. A reference bandwidth is default, and by default it is 100 megabit per second. And here you might face some problem because if you have interfaces higher with speed higher than fast Ethernet or 100 megabits, you will not see any differences, because if you divide, let's say, 1 gigabit, 100 megabit by 1 gigabit, you will get 1 because it will round it to 1. So all costs from fast Ethernet and above will be equal to 1. To change this, we need to change reference bandwidth, and we need to change reference bandwidth on all our OSPF routers. Conf T router OSPF 100, and to change it we need to do auto cost reference bandwidth, and I'm gonna do 10 gigabit. Conf t router OSPF 100 reference band auto cost reference bandwidth 10. You need to enter in megabits per second. So 10,000 is 10 gigabit. Okay, and the last one, this one. Router OSPF 100 auto cost reference bandwidth 10,000. Okay, let's see now. So we had two costs to these networks, and let's see what we have now. Show IP route OSPF, and now you can see that we have 20. So 10 is for this one, for this link. This router is unmanaged, switch is unmanaged switch. I'm not counting this. And 10 for this, for each of these links. So in total 20. But you also can change a cost on the interface. Conf t interface G0, let's say 1 IP OSPF cost, and in this way you can manipulate of routes on your router. Let's say 50. And now let's check what we got. So this will change this route to 60. As you can see, it is 60 now. So I changed cost on the on this interface for OSPF and set it manually. So the same way you can manipulate it with any routes, changing the costs. Next, I want to show timers. Show IP OSPF interface G00. By default for broadcast for LAN networks, this hello timer is 10 seconds, dead timer 40 seconds. If you change these timers on one router, you need to change timers on the neighboring router, otherwise they will not form neighbor adjacency. This one I will show you. Conf t router OSPF 100 interface G00 IP OSPF, and then we have option hello interval and dead interval. Hello interval, and you can enter from 1 to 65,000 seconds. Let's say 5. The same you can do for dead interval. Let's do it also for dead interval. Let's set it to 10. Now I'm going to lose neighbor adjacencies with routers R1 and switch SW2 OSPF neighbors. 10 more seconds. Show IP OSPF interface G00. Hello 5, dead interval 10. Yes, I lost this. Show IP OSPF neighbors. I don't have I don't have any routers in the where my switch SW1 formed neighbor adjacency with, and let's fix it. Interface G01 IP OSPF hello interval 5 and IP OSPF dead interval 10. And let's go to this one. Interface G00 IP OSPF hello interval 5 IP OSPF hello dead interval 10. Now we should form already formed neighbor adjacency with our two routers. Show IP OSPF neighbors. Everything is good. And the only thing I also want to mention that you should never change that interval to value less than hello timer. Otherwise, your router will never form neighbor adjacency, because once that timer reach 0, router considers neighboring router as dead. So if your that timer is less than a hello timer, you will never receive hello packet. You will always reset this connection to dead. Okay, and the last thing I wanted to show this DR and BDR placement. At the moment, show IP or OSPF interface brief. Show IP OSPF neighbors. At the moment, router R2 is DR, router R3 is BDR, and router R1 DROTher. I want to change router R1 to DR, router R2 to BDR, and switch SW2 will never be neither DR nor BDR. To do this, I need to change OSPF priority for this switch SW2 conf T IP router OSPF 100 IP OSPF priority OSPF priority IP OSPF priority. Sorry, it is done on the interface by interface basis, because routers form DR-BDR relationship on the interface. So IP OSPF priority, and you can set from 0 to 255. 255, if you set 255, in most cases, if there is only if there is one more router with the same priority, this router is gonna be DR. So SW3, if you set to 0, this router will never take part in the DR-BDR election, and it will never be neither DR nor BDR. So this one is gonna be 0. I don't want it to take part in any election. Show IP OSPF neighbors. Now you can see now router R2 still DR, and router R1, router R2 or switch SW1 DR, and router R1 is BDR. So let's change this conf T interface G0001 IP OSPF priority, and let's set it to 55. As you can see, nothing has changed. Router R2 still DR, router R1 still BDR, but the priority is changed. For this to take effect, I need to reset process on router switch W1 or router R2, because there is no preemption in DR-BDR election. Clear IP OSPF1 process. And show IP OSPF neighbors, and I can see on SW2 switcher I have priority 0, which I set before, and show IP OSPF neighbors. Now, as you can see, that what I wanted to get. Router R1 is DR, and switch SW1 or 2222 is BDR. And let's also check connectivity from our hosts. Let's do it. Cisco, and ping 192.168.1.1. As you see, it is successful, so I have full connectivity from host through internal network to, let's say, outside network. So this is everything I wanted to show in this configuration example. Thank you very much for your attention. Don't forget to subscribe to channel and with notification bell on, and hit like button to this video. Thank you very much.
Thank you very much for watching my video. I hope you enjoyed it. Please don't forget to subscribe to my channel with notification bell on and show your support by hitting like button. I hope to see you soon in my next videos, but for now just goodbye and see you soon.